Good evening. This is Professor David J. De Los Reyes. Okay, my topic for tonight will be an example problem on the solution of an exact differential equation. This is lesson number 32 on my course differential equation. This is lesson number DE32. That's a continuation of the past lesson 31. The topic is differential equation, and the exact topic is exact differential equation. This is the fifth type of differential equation that we have been studying. Okay, I will give you an example problem on how to evaluate an exact differential equation for tonight. Okay, let's proceed. Evaluate the given differential equation is 2x minus y plus 2 close quantity dx minus open quantity x minus 1 over y close quantity dy equal to 0. We are given this differential equation here. It is of the form m as a function of x and y times dx plus n as a function of x and y times dy equal to 0. This was the form of the exact differential equation under concepts that I gave you the last time around. M as a function of x and y times dx plus n as a function of x and y times dy equal to 0. Okay, let's proceed with the solution. Expand. If we try to expand, okay, this 2x here plus 2, we combine it as 1. So that is 2x plus 2 times dx minus y dx. And if we try to multiply this will be minus x dy, minus x dy. This is minus 1 over y dy. This will become plus dy over y equal to 0. If we try to visualize the expansion, the first one is, I place it here, directly integrable. Why directly integrable? It is just a pure function of x, hence dx. Okay, this one, a pure function of y and dy, this is also directly integrable. So this portion here, plus this portion, I termed it as di, those directly integrables. Those are easily integrable, so but it's a part of the solution. Our only problem now is the resulting not directly integrables, these two here. This is minus y dx minus x dy. I term it as not directly integrable or just simply NDI. Okay, let's try to integrate those that are directly integrable. We will copy this one plus this. So those directly integrables will be the integral of 2x plus 2 dx plus the integral of dy over y. It is this. It's an easy one. This is 2, the integral of x dx, we bring it out. 2, the integral of dx plus the integral of dy over y. We've been saturated with problems under integrals, so this is an easy thing for us. So this should be 2. This is power formula, x squared over 2 plus 2. The integral of dx is just x. The integral of dy over y is natural logarithm of y. So a part of the solution, di, meaning those directly integrables, will be x squared plus 2x plus natural logarithm of y. That's a part of the solution. Let's try to bring out the main problem, the integral of those not directly integrable. Actually, there are two, right? Y dx and x dy. We forget for the meantime the negative sign. Later on the final answer, we will place the negative. Those not directly integrable, it will be equal to y dx plus x dy. So in here, m is y, x is n. Okay? If you take the partial derivative of m with respect to y, partial derivative of m with respect to y equal to 1. Okay? the derivative of m with respect to y is 1. We are differentiating with respect to y, so this will be 1. For n equal to x, the partial derivative of n with respect to x is also 1, because we are differentiating with respect to x, so this should be 1. Since the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, since they are equal, this part of the solution is actually exact differential equation. As you can see, it is just simply the differential of xy. So it will be x times dy plus y times dx. And what is this? It is this. It is an exact differential. And what is the exact differential? That's what we are looking for. Solution number 1. For those not directly interpreted, for the solution of this, solution number 1, it will be the integral of m dx. Just take this portion here, integrate it. But take note that while you are integrating the integral of m dx, treat y as constant. So if y is constant for the meantime, we could bring it out from the integral sign. So this should be equal to the integral of y dx. And since y is constant, we could bring it out, right? So this will become y, the integral of dx. Y, the integral of dx is just x plus c. So the solution of this one is just actually the product xy plus c. Solution number 2. Solution number 2, it could also be the integral of n dy. Integral of x dy. While you are taking the integral of n dy, treat x as constant. So x could be taken out. So this will be x, the integral of dy. So this should be x. The integral of dy is just y plus c. Not directly integrable is still xy plus c. They're the same. So no matter what kind of solution you will bring it out, it will still be the same. Okay? So the total general solution now, take the sum of di plus ndi. So general solution will be, this is the di, and this is the not directly integrable. Plus c equal to 0. That's the total general solution. As you will see it, if you try to take the differential of xy, it is actually y dx plus x dy. It is an exact differential equation. That's why our topic for tonight is exact differential equation. Okay, that's it guys. That's how easy to solve a problem under exact differential equation. So for those who are taking up differential equation, this is for you guys. If you want to subscribe to my channel, please click subscribe. Thank you. Good evening, Los Angeles.